Chapter 7, Section 1, Describing Reactions. Chemical equations are a useful way of describing change before and after the change occurs. You will have reactants and products. Your reactants are the substances that change, what you put into your chemical equation. Your products are the new substances that are formed, or your results, what you get out of the equation. So for example, your reactants yield your products. Carbon plus oxygen yield carbon dioxide. So C plus O2 will give you CO2. Now with any type of chemical equation, we have what's known as the conservation of mass. That means that mass is neither created nor destroyed in a chemical reaction. So what you start with has to equal what you end with. Your total number of atoms in the reactant side has to equal the total number of atoms in your product side. So this is where balancing equations come in. You take the number of atoms in an element before the reaction, and that has to equal the number of atoms of the element after the reaction. And we do this by using what's known as a coefficient. It is a number that appears before the formula, kind of like a multiplier where you can distribute in math. So for example, we have N2H4 plus O2 yields N2 plus H2O. So let's go ahead and look at our reactants. We have 2 nitrogen, 4 hydrogen, and 2 oxygen on the left hand side of the arrow. Those are your reactants. That's what's going into. The yield, the products, what you're getting out is 2 nitrogen, 2 hydrogen, and 1 oxygen. Now as you can clearly see, 4 hydrogen is not equal to 2 hydrogen. 2 oxygen is not equal to 1 oxygen. So here we're going to choose a multiplier that we can put in front of a formula to become a coefficient. So in order to take 2 hydrogen and make it 4, what number can we multiply by? Well, 2 times 2 gives you 4. So that 2 that you're multiplying by is your coefficient. We stick it in the front. Now we're not done quite yet, because just like in math, not only does it apply to the hydrogen, it applies to the oxygen as well, just like distribution. So we also have to multiply our oxygen by 2 as well. 1 times 2 equals 2. Now let's take a look at our reactants and products. We have 2 nitrogen and 2 nitrogen, 4 hydrogen, now we have 4 hydrogen, 2 oxygen, and now we have 2 oxygen. So this is now a balanced chemical equation. So this is your result. N2H4 plus O2 yields N2 plus 2H2O. Let's go ahead and look at another example. Let's use copper and oxygen. Cu plus O2 yields CuO. Our reactants, 1 copper and 2 oxygen. Our products, 1 copper and 1 oxygen. So again, you can see our coppers, those are already equal. However, we have 2 oxygen in the reactants and 1 oxygen in the product. So we need to multiply 1 by some number to get 2. 1 times 2 equals 2. That is our coefficient. So we plug in 2 in front of CuO. But again, it doesn't just apply to the oxygen. It applies to both the Cu, the copper, and the oxygen, the O. So we also have to multiply copper by 2. So now we have 1 copper on the reactant side, 2 coppers on the product side, 2 oxygen on the reactant, and 2 oxygen on the product side. So now we need to take a look at our copper. How do we multiply 1 copper on the reactant side to get 2 copper on the product side? Well, 1 times 2 equals 2. And again, our multiplier is what goes in front as our coefficient. So now we have 2 copper on the reactant, 2 copper in the product, 2 oxygen in the reactant, and 2 oxygen in the product. Now it's equal on both sides. So our final formula is 2Cu plus O2 yields 2CuO. That's your final example. Now there are 2 practice problems that I would like for you to look at. The first is H2O2 yields H2O plus O2. Go ahead and work that one out in your notes. I will be checking for the correct answer. The second one I want you to work out is Mg plus HCl yields H2 plus MgCl2. And go ahead and put that one in your notes as well. And that's it for today.